Okay, section 13.3, we're going to look at factoring using the difference of squares. But first, I want to review factoring using MAM with this example. So we've got MAM, our multiply, we have 4 times 6. 4 times 6 gives me 24. And then our add is 11. So if we look, we have 1 times 24, doesn't give us 11, 2 times 12, no, 3 times 8, 3 times 8, if we add 3 plus 8, that gives us 11. So that is our answer, 3 times 8. Now I can split my variable and drop down my coefficient to get my two fractions. I've got 3 on one and 8 on my other. This one, first one, I can't simplify, but I can simplify my second one here. 4y over 8 is just 1y over 4. So I have my two fractions that I can write my binomial. 4y plus 3 for my first one, and y plus 4 for my second one. So that is a review of MAM. Next, we're going to look at binomials using difference of squares. So this is done when we have a binomial that looks something like this. We have some a squared minus a b squared. And the way it works is we take our a squared minus b squared. If you took the square root of both those numbers, you would get your a and your b, and you would be able to fill in our binomial. So let's look at an example. If we have x squared minus 25, and remember, this only works when there's a minus sign in between. X squared minus 25. Take the square root of both of those numbers. Square root of x squared is x, and the square root of 25 is 5. So now I can use this formula right here. If my a is x and my b is 5, I get x minus 5 times x plus 5. And that's my answer using my difference of squares. So if I look at my next term, 2, if I take the square root of both those terms, the square root of 16a squared, well, the square root of 16 is 4, and the square root of a squared is a. So that is my answer for the first one. And then the square root of 49b squared, I get 7b. So now I can take those numbers and fill them in. For my a, I have 4a. For my b, I have 7b. 4a minus 7b, 4a plus 7b. Okay, let's look at the next few. Again, number 3, square root of 9a squared and the square root of 25. Well, the square root of 9 is 3, and our square root of a squared is just a. And square root of 25 gives me 5. So I get 3a minus 5 times 3a plus 5. Then over here, if I look at the square root symbols over here, if you type that in your calculator, square root of 2 and square root of 21, you're not going to get an even number. So this one is prime. Cannot take the square root, so we can't factor that one. Okay, number 5. If we take the square root of x to the 6th. Remember, when we have an x with some number up here, so if we said x times x squared times x squared, we add our exponents right here. That would give us x to the 4th. When we take the square root of x to the 6th, we are going to divide this number by 2. So when we do that, we get x to the third for our square root of this term, and the square root of 1 is just 1. So that leaves us with x to the third plus 1, or minus 1 comes first, x to the third minus 1, x to the third plus 1. Okay, one more. We could take the square root of both these terms, but if you noticed, this equation is different from all our others because it has plus sign in the middle. This right here means it cannot be factored. It is a prime binomial because of that plus sign. So we could still factor these, but we could not use this equation because it's got a plus sign and not a minus sign. One way we can use factoring is to break down area into its component lengths and widths. So that is our blank here. Factoring is how we do that. So if we look at some examples here, it says use factoring to find the dimensions of the figures drawn below if the areas are given by these equations here. So if this is our area, we want to know what times what gives us that equation. So if we use our MAM factoring, break it up into multiply, add, multiply. We have a 1 out here. A 1 times 9 gives me 9. And they need to add to 6. So if I have 1 times 9, doesn't give me 6. 2 times, nope, can't do that. Try 3 times 3. 3 times 3 is 9, and 3 plus 3 is 6. So that is what I'm looking for. Then I'm going to break my coefficient. I have a 1x and 1x with 3 on the bottom of both of those. I can't split those up, so my answer is going to be x plus 3 times x plus 3. That is equal to this equation that I started with. So if I have this times this, remember my area is my length times my width. That makes my length x plus 3 and my width x plus 3. So I can find each of those pieces by factoring this equation. So let's do one more. We label our MAM. We have 3 times 2 is 6, and then we add them to get 7. So we start at 1 times 6. 1 plus 6 is 7, so that is what we are looking for. We break 3x squared. We have 3x and 3x. We drop our coefficient and split our variable. And I have 1 on the bottom of 1 and 6 on the bottom of my other fraction. 3 over 1 can't be simplified, but I can simplify 3 over 6. I get x over 2. And now I can take my two fractions and write my binomials. I have 3x plus 1 and x plus 2. So this tells me that my length and my width here, I'm going to have 3x plus 1 and x plus 2. So my length looks like it's the longer side. I will put this one as my longer one, 3x plus 1, and then x plus 2 as my width.